Happy day to all. I'm Dr. B. Yamini. This is the part 3 video for an overview of an email security. In previous video, we have seen about PEM. PEM as privacy enhanced mail. In that, we have seen about 4 requirements. The first requirement was canonical representation that we have seen in the previous video itself. What is canonical representation? It is what the general format in traveling from source to the destination for the emails, which does not depend on the architecture or the operating system, is what called as canonical representation. And in this video we are going to see about digital signatures, the rest of the topics: digital signature, encryption, and base 64 encoding. What is digital signature? Your email, whatever email content you are sending, must be applied on which you'll be applying message digest algorithm, that is MD2 or MD5, so that you'll be getting a message digest in bit formats. On this message digest, you'll be applying an encryption algorithm. You'll be using an encryption algorithm using a private key. So I'll be using my private key, and you people, the authorized persons, will have my public key also. While in the case of a symmetric encryption, what they will try, if I use my private key, the authorized persons will use my private public key in order to open the message. So this is what sender's private key. So it is my private key I am using here. The authorized person will open the message by using what? My public key. Okay, and that is how the digital signature has been created for the email whatever you send. So this is for authentication purpose. And the next one is encryption. The message whatever I am sending must be appended with digital signature that I have generated in the previous step, right? So the message must be appended with the digital signature which I generated by using a message digest algorithm, and then encryption using the sender's private key. So that appending should be done. That is, next to email, the digital signature should be appended, and which again will get encrypted using a symmetric key. What is symmetric key? Both the sender and the receiver will use the same key. That is what called as symmetric key. So this encryption may be done by DES, data encryption standard, in cyber block chaining mode. So this is what DES in CBC mode, and the answer whatever you're getting is the encrypted result. That is the cipher. You'll be getting this cipher. You'll be transmitting through the internet. So DES is data encryption standard. CBC is cipher block chaining. And the next one is base 64. Fourth topic is base 64 encoding. How it is encoded here means, so totally 24 bits of 3 parts, that is 8 parts, are get converted into 6 bits of format, right? So which means that here also 24 bits, and here also what? 6 4s are 24 bits. 4 concatenated 6-bit groups used as what? Index here in 64-bit encoding. The main aim of this is to convert your 24-bit into 32-bit. So that is what. So first 24-bit is getting splitted into 3 8 parts. Then again I am splitting that into what? 4 6 parts. So what happens now? I am applying base 64 encoding. The base 64 encoding has its own base 64 table also. So for that bit representation, it will be converting it into a character. For that character, I will be converting it into what? For every character, I will be converting it into a what? The ASCII format of 8-bit. So this is what? 4 characters of 32 bits stored in 8-bit ASCII format. So what will happen? For every 6-bit, I am having what? Base 64 encoding table. In base 64 encoding table, one letter will be there. For that letter, what will happen? I will be converting it into ASCII format, 8-bit ASCII format. So if I am getting A here, let me consider it is 96. So for 96, what is the representation of 8-bit? That will be stored here. Like that, for every letter, I will be converting it. So what happens? Here it is 24. Here it is how many bits? While converting it with ASCII, it is 32 bits. 8 4s are 32. So it is of 32 bits. So this is about base 64 encoding. So that's it about an overview of email security. Thank you.